Our time on this planet is filled with arrivals and departures. As every organism enters life, moves about, and finally takes its leave, whole populations are affected. Birth, death, immigration, and emigration are all factors that contribute to the growth and decline of populations.
Population is a group of individuals of the same species living in a certain area at a given time. In this program, you will see how birth and death, as well as immigration and emigration, affect both the size and density of a population. By the end of the program, you will understand the population cycles of many species, including humans. And finally, you will have a glimpse at chaos theory and how it applies to population growth patterns.
So, this is the supposed great fishing spot?
Well, that's what my dad was telling me. You know that once he caught this great big fish here.
Sounds like a fishy story to me. We need a more scientific way of figuring out the population here. Then maybe we can predict the number of fish in the lake.
Well, actually, I was reading in the chapter that was assigned for homework last night, and it was saying something about how to calculate population growth.
Well, that would help, because I'm calculating zero growth in our fish bucket.
I guess in that case we can quit fishing for today, and I can get that water sample I need for my brine shrimp experiment. Joelle, could you come over here and give me a hand for a second?
Sure, what do you need?
Well, I'd like you to count out 60 shrimp eggs for beaker A while I finish counting out 60 eggs for beaker B.
Sure. What are you going to do with them when they hatch?
Well, they're going to have to be fed, so Beaker A is the one that's only going to be fed once during the 2-week period, and Beaker B, they'll get fed every 2 days.
Well, what are you going to feed them?
Actually, all they really need is a couple granules of yeast dissolved into their water.
Really?
Yeah.
So what are you going to do with all this once you get it all?
Well, I'm hoping we can use it in class later to help us analyze some population growths.
Neat.
In order to study population growth, we need some initial information about the population. Cameron and Joelle have been doing some studies on population growth. Cameron, where did you start?
Well, population size was one of the pieces of information we needed, so I started with a population count.
What did you count?
The brine shrimp right here, actually. There were 33 in Beaker A and 106 in Beaker B as of today.
Very good. How about you, Joelle?
And as of today, there are 14 fish inside one of my aquarium and 16 on the other side.
Now, I noticed that you made a point of saying side 1 and side 2, plus you made a point of saying today. Cameron, you also made a point of saying Beaker A, Beaker B, and today. Why was that?
The proper definition of population size is the exact number of individuals of a certain species
In the same region at a certain time.
Very good. You know your definition for population size. What next?
I guess next we have to determine if the population size changes over time. There would be 4 factors that could affect population growth.
What are those 4 factors?
Those 4 factors would be mortality, natality, immigration, and emigration.
Very good.
Natality is a positive factor because it describes the number of individuals born into a population. Natality, therefore, increases a population. Mortality is the number of individuals that die, so it's a factor that decreases a population. Immigration is the movement of organisms into a region from another area. This, again, increases the population in that region. And finally, emigration refers to organisms moving out of the area, reducing the population. These four factors, along with the environmental conditions, enable populations to be dynamic systems. These systems interact and exchange energy and matter in the environment. Mathematical formulas are used to analyze these systems.
Air Canada is reaching Mr. Eric Hawk. Mr. Eric Hawk, please contact Air Canada for message.
Let's develop a formula to calculate the change in population size. Now, what variables would we need?
Well, if you added births plus immigration, we'd be adding a lot of new individuals to a population.
Good.
And there's deaths and emigration. Those are the individuals decreasing the population. So if you subtract them from the new individuals, you get the change in population size.
Yeah, right.
So then, delta N, or the change in population size, is equal to births plus immigration minus deaths plus emigration.
Good.
Yeah, and if the number of deaths and emigration is greater than the births and immigration, you get a negative number, which means the population is decreasing.
Exactly.
To study populations, so far we have counted the number of individuals in a population, and we have calculated how that can change. Is there any other measurements we can make?
Some populations are more crowded than others.
You mean more dense?
Yeah, I guess so.
Isn't that called population density?
Yes, it is. Does anyone know the definition?
Density is the number of individuals in a certain space.
Right. So the more individuals in a certain space, the more dense it is. We can calculate the density of a population. To do that, we need a formula. D equals N divided by S. D is population density, N is population size, and S is the space in which the population lives. Let's calculate the density for your populations using that formula. Cam, let's start with your brine shrimp.
Okay, so if we took B as an example, it would be 106 divided by 100 milliliters, which would be 1.06 shrimp per milliliter.
Good. How about your fish population, Joel?
The fish population in section 1 of the tank is 21 fish divided by 15 liters, or 1.4 fish per liter.
Very good. Now, population density can change over time. Any ideas what would lead to a change?
Since population density depends on the number of organisms, the factors that affect those organisms would also affect the density.
So you mean births and immigration would increase density, and deaths and emigration would decrease density.
Right. Plus change in the space where the population lives would also affect the density.
And that's a very good point. For example, human development often decreases wildlife habitat, and that leads to an increase of certain population densities. So far, we have talked about natality, mortality, immigration, emigration, and space as affecting the density of a population. We need to take into account two more factors, and that would be whether the population is open or closed. How would you categorize your populations?
Well, seeing as the shrimp aren't able to migrate from one beaker to the other one, I'd have to say that this is a closed population.
Okay, how about you, Joel? How would you describe your fish populations?
Okay, the fish can freely move within the tank between the two sides, so I say that they were open populations.
Right. Okay, so then we can say that a closed population is one that is only affected by natality and mortality. Now, an open population is one that is affected by mortality, natality, plus also by immigration and emigration. Cam,